Okay, we are finding the roots. Wait, I can't give away that answer. Okay, so we're finding the roots, and we're going to do it from vertex form first. So we got a quadratic function right here, and we're trying to figure out what the roots are. It's in vertex form right now, which is like not the best form for finding the roots. It's really nice for finding the vertex. So we can see the vertex is at 5, negative 32, so that's cool. So how are we going to find the roots? So it's not really that easy to factor this or like get it into factored form. So since we know that roots, which are x-intercepts, they occur when y is equal to 0. Basically, we're trying to figure out, hey, what does x equal? Whoops. What does x equal when y is 0? So let's go ahead and sub 0 into our equation. That seems like a good first step. And now we need to figure out what x equals. So I'm thinking we just try to get x alone and figure out what it equals. So I need to get rid of this 2, this negative 5, this 2 squared guy, this negative 32. I got to get rid of all that stuff. So I'm going to start from the outside, like with this negative 32, and work my way towards x. Okay, so I'm going to add 32 to both sides to get rid of the 32. Okay, first step done. Now, I need to get rid of this 2 in front of the brackets. So I think I shall divide both sides by 2. So 32 divided by 2 would be 16. And then I have x minus 5 squared. I'm getting close. X is almost alone. Next, I'm going to get rid of this square root. I just gave away my question. I'm going to get rid of that power of 2, the squared thing. And the way I'm going to do that is, I know the opposite of squaring something is square rooting it. So I'm going to square root both sides. And what happens is the square root and the squared cancel each other out because they're opposite operations. So they're gone. And then the square root of 16 is actually 4, but it could also be negative 4. So I'm going to say it's plus or minus 4. Why is that? Because the square root of 16 just means 2 of the same number that multiply to 16. So negative 4 times negative 4 is positive 16. Okay. Now I got to solve this equation. So I'm going to break it up because I know I have a 4 equal to x minus 5. And I also have a negative 4 is equal to x minus 5. And I'm going to try to get the x alone. So I'm going to get rid of the negative 5s. So by adding 5 to both sides. So here I'll get 4 plus 5 equals x. So x is equal to 9. That's one of my roots. And then on the other one, I'm going to add 5 to both sides. So I can see that x will be equal to 1. So there you go. Those are my 2 roots. So when y is equal to 0, x is 9 and 1. So that's how you can find roots from vertex form. All right, what if we have, I'm not going to do this whole one. I'm just going to kind of set it up for you. But what if we had an equation, like let's say we had 2x squared minus 6x minus 12, I don't know, 11. No, wait, I'm just going to make it smaller. Minus 3. Okay, let's say that was our equation, and we wanted to find the roots. So right away by looking at it, I know that I don't know 2 numbers that multiply to multiply to negative 6 and add to negative 6. No way. So like I know I can't factor this. I can't factor it. I can't factor it. It's in standard form. How am I going to find the roots? So you can go to your handy friend, the quadratic formula. The quadratic formula can help you, determine the value of x when y equals 0. And it looks like this. X equals negative b plus or minus the square root of b squared minus 4 times a times c and the whole entire thing is divided by 2 times a. That's your quadratic formula. So you can actually use that if you can't factor, it's not in vertex form, like you think, oh, I don't have any other options. You could put that in vertex form if you want to, but let's say you don't. Okay, let's try using the quadratic formula. Okay, so we know that a is equal to 2, b is equal to -6, and c is equal to -3. Now, before you do the quadratic formula, it might be kind of handy to just like make sure it's going to work. So this square root guy, that's your test. If you can't get a positive number under there, you're not going to have any roots. So why don't we just test that out before we even do this quadratic formula? Let's just see, like, what does b squared minus 4ac equal? Because we need it to be positive or else there's no point in doing this question. P.S. We call this b squared minus 4ac. We actually call that guy the discriminant. Oh God, I'm like the worst speller. There we go. The discriminant. So that guy can kind of help us just figure out if something's going to have roots, no roots, 1 root, 2 roots. So if we pop in -6 squared minus 4 times 2 times -3, and we just see, okay, so I'm going to go slow here. So 36. And then if I multiply all these things together, I've got 4 times 2 is 8, and then 8 times 3 is 24. And then since I've got these two negatives, I get positive 24. It looks like I'm going to have some roots. What is that, like 60? Is that right? So we're definitely going to have some roots. So since the discriminant, which is this guy, is positive, so this guy's positive, we will definitely have 2 roots. Check. So now you can just use the quadratic formula to solve this. I don't feel like I want to because I don't have a calculator, but let's just start it off. Okay, so we would plug all these values into the quadratic formula. So we'd do -b, which since b is already negative, it would be just positive 6, plus or minus the square root. Hey, I already did that part. b squared minus 4ac, which ends up being 60, but I'm just going to write it in case. So -6 squared minus 4 times 2 times -3. And the whole thing is divided by 2a. So 2 times 2. Okay, so if I just simplify that a bit, 6 plus or minus, I already got 60 for that, assuming I did it right. And 2 times 2 is 4, so we'll just simplify it a little bit. Okay, cool. And then you could split it up and you would do 6 minus root 60 divided by 4. And you could also do 6 plus root 60 divided by 4. And you could solve it if you wanted to, like get some decimal numbers, or you could simplify it a little more. Yeah. We're going to learn actually later on how to simplify radicals. But anyways, yeah, that's how you do the quadratic formula. It's, to me, kind of like your last resort, though. You don't want to go to this guy often because it's kind of annoying. You want to try to factor or use vertex form, but if all else fails, there you go, quadratic formula. And the discriminant's really handy for being able to tell if something has 1 root, 2 roots, or no roots. And just to remind you, so a little reminder, if you get a positive value, you're going to have 2 roots. If you get a 0 underneath the square root, so if the discriminant is 0, you're going to have 1 root, which makes sense, right? Because this plus or minus guy is the thing that kind of gives you 2 roots. So if you're adding or minusing 0, you're going to get the same answer. And then finally, if you get a negative number under the root sign, you're going to have no roots because you can't square root a negative. So there you go. The end.